In this question, it says, a call center is looking into the wait times for their staff to take a call from customers. It is speculated that the average wait time for customers to reach a service agent is 540 seconds. Management thinks the average wait time is actually less than 540 seconds. To prove this claim, a sample of 16 calls were taken, and the mean wait time was found to be 510 seconds, with a standard deviation of 45 seconds. At alpha equals 0.01, is there enough evidence to support the claim that the mean wait times is less than 540 seconds? So in this example, once again, first we ask, what is the size of the sample we're dealing with? And you can see then that n is less than 30, which implies that we are going to use a t-value when it comes to finding the critical values. First, we're going to start off with stating the hypotheses. There's our null hypothesis and our alternative. Pause the video and see what you come up with. Well, from our statement, we can see that it's asking the claim that the wait times is less than, so the mean is less than 540 seconds. Which means then that in this case, the null hypothesis is greater than or equal to 540 seconds. Okay, so that's our first order of business. Second order of business is to find the critical values for this question. Now, in this case here, the alpha is 0.01. In other words, the probability of rejecting our null hypothesis when in fact it's true is 1% in this case. Now as well, because we have a direction given, we can say that this is a one tail, and since it's pointing to the left, it's less than. This is a left tail situation. So when we put our diagram together, it's going to look something like this. With our mean in the center, and we're going to have our tail on the left-hand side, and alpha is 0.01. And we need to go and find the t-value that is going to separate the rejection region or critical region with the non-critical region. Now, with that said as well, we are using a t-value, and the t-value is going to be what degrees of freedom in this case is 16 minus 1, which is 15. So we need to look at the one tail with alpha 0.01 and degrees of freedom 15. So looking at our t-table, we're going to go and, first of all, it's a one-tail test, so we are looking at this row here, 1%, so 0.01. So it's this column here. Degrees of freedom was 15, and so where those two values intersect, that is going to be our critical value. So 2.602. So in this case, t is equal to 2.602. And actually, we're missing one small thing, and that is negative 2.602. Because it's on the left-hand side of the mean, that means the value has to be negative. So now we know our critical value, or the fence in this case, is going to be negative 2.602. Next, we're going to look at the t-score. So, we're going to perform the test. And once again, in this case, that's t is equal to the sample mean minus the proposed mean divided by standard deviation divided by square root of sample size. And according to this, the values are 510 minus 540 divided by 45 divided by square root of 16. And what does this give us? Well, that gives us minus 30 on top divided by 11.25, which then gives us a final value of negative 2.667 rounded to 3 decimal places. All right, so let's go put that down into our picture. And according to this, 2.667 is going to be in this region here. All right, so that's our test value. Okay, so you can see then our decision in this case is to reject our H naught. So our decision is to reject H naught. Okay, and then final statement. So once again, let's just look at that. We're going to reject. So we are rejecting H naught. So we are going to reject this, and that means we're not rejecting this claim here. Okay, so we can then say that based on our evidence, the mean time to reach a service agent is in fact less than 540 seconds. And just let me get rid of that little value here. There we go. I don't want it to look like it's an equal, because that only applies to the null hypothesis. All right, so final statement then in the end is our sample data indicates the population mean wait time is significantly less than 540 seconds. Once again, just a 5-step process, and followed by the fifth being what it is that you've actually determined in this case. We're going to try another example on the next video.